Okay, let's take a look at this absolute functions review. So we've got our first part, graph each function, fill in the table of values, and identify the specified attributes of each graph. And we're given for number one, the function f of x equals 3 times the absolute value of x plus 2 minus 5. Now, first thing we need to remember is that our template is y equals a absolute value x minus h plus k, where our vertex is going to be h comma k. So if we look at our function that we're given, we've got a positive 2 here and a minus 5 here. Now because of the minus h, we're going to flip the sign, negative 2, and we're going to keep the sign for the k because it's just a plus k, so minus 5. And there's our vertex. And if we think about it in terms of transformations, we've shifted left 2, and we've shifted down 5, and there's our vertex. All right. So our second part, our axis of symmetry. Our axis of symmetry goes through our vertex and we write it in terms of our x value. X equals negative 2. Now, while we're over here, let's go ahead and take a look at this last piece. Our 3 is our a value, which is our slope of our right side. Slope. So remember, slope is rise over run. So if we come over 1, up 3, we drop a dot there. Over 1, up 3, we drop a dot there. And then we use our axis of symmetry, which tells us that there's another dot right here, opposite side of the axis of symmetry, same distance, and another dot here, opposite side, same distance. And now we have sufficient points to do a quick sketch of our graph. And I put the arrows on the end to remind us that they go on forever. So now looking at our next piece, increasing, decreasing. As we go from left to right, our y values are initially going down until they reach the vertex. Remember, the definition of the vertex is where the graph changes direction. So our decreasing interval is going to be from negative infinity to negative 2. Remember, intervals, increasing, decreasing intervals in terms of x values because we're going from left to right, and that's the x-axis. Once we hit the vertex, now we start going up in our y values. So our increasing interval, negative 2 to infinity. So our x value of our vertex is going to be the transition point where our graph changes directions. Therefore, it's going to be part of our increasing and decreasing intervals. Now for our domain is the set of all possible x values. And if we look at this, since we have those arrows, our graph is never ending in terms of x. So our domain is negative infinity to infinity, which is the domain for all absolute value functions like this. Now our range, we're going to start at negative infinity, and we're going to come up towards the top. Now what we're looking for is where our graph begins. And it begins at negative 5. So negative 5 is the start of our range, and it continues on to infinity. And I use a bracket because negative 5 is on our graph. In fact, when x is negative 2, y is negative 5. Now, x-intercepts, we can see we've got an x-intercept here, color, x-intercept here and an x-intercept about right here. And ways you can find these is you can do it mathematically. You can set your y value equal to 0 and solve for x. You can do it on the calculator by graphing your function, graphing y0 into y2, and then finding your intersections. Or we can use our slope to our advantage here and recognize that since we're going up one, or over 1 up 3, that this is 1/3, this is 2/3. So we have 1x at negative 1/3, and then 1/3, 1/3, 2/3. So we have another one at x equals negative 3 2/3. Our y-intercept is just right here at y equals 1. Remember our transformations we talked about, our initial two, that we had shifted left 2. I'm just going to say left 2. And then we had shifted down 5. And then our last transformation comes from our slope of 3. And since that's larger than 1 and it's our a value, then that's a vertical stretch by 3. Now, for our table of values, if we graph it on the calculator, we can go to our table of values on the calculator and get them that way. We can solve for each one of these if you want to be brutal to yourself. Or again, we can leverage our slope. Now we know already that at negative 2, x equals negative 5. And we also know that at 0, x is 1. And we can use our slope over 1 up 3. So over 1 from negative 2 to negative 1 up 3 puts us at negative 2. Another 3 puts us at 1 like we already know. Another 3 puts us at 4. And because we have our axis of symmetry, it's just a simple matter to copy those values in the same order away the other side. So that's problem 1. If you want to hit pause now, and we'll move on to the next one. Now, number 2, same exact concept. So I'm going to go through this one a little faster, and I'm just going to fill in the values. One thing, we have this 2 inside, which is technically in the B position. And we haven't talked about those because it's real simple. If you bring that B value out, factor it outside, which you can, we end up with negative 2x minus 1 plus 3, and now we're in our standard form. So our vertex, 1, 3, from our h and our k. Our slope is negative 2, so over 1 down 2, over 1 down 2, over 1 down 2. Use our axis of symmetry of x equals 1 to come back and mirror those points. Sketch our graph. Our increasing interval in this case is from negative infinity to 1. Our decreasing is from 1 to infinity. Our domain, as always, with absolute value functions of this type, negative infinity to infinity. And our range here, since we're starting from the bottom and going up, we're starting at negative infinity. We see our graphs going down forever. So negative infinity is the start of our range. And in this case, 3, our y value of our vertex, is the end of our range. And again, a bracket. We have 2 x-intercepts. We have one at x equals negative 1/2, and another at x equals 2.5 or 2.5. And again, we have a y-intercept at y equals 1. Transformations, you can see from where the vertex is from the origin that we've went right 1. We've went up 3. we have a vertical stretch by 2. And since we're now facing down, we have a reflection over the x-axis. So same thing with our table of values here. We start with our 3 here, and we know we went down 2 for each one. We went right. So this goes to 1, this goes to -1, this goes to -3. And likewise, because of our axis of symmetry, 1, -1, and voila. So you can hit pause here. And now moving on to the next one. All right, number 3, fairly straightforward. We're going to do the same thing again. We can see from our function that we have a vertex at 80, 60. Now, because weekly sales in thousands and then T is time in weeks, we know this is going to be time, this is going to be sales. So what I would recommend is we divide our error here and we put our 80 right here. And then we come over, so let's label that 80. And then we come over here somewhere, and it doesn't really matter. We're going to put our 60 here. So we can do 30, 40, 50, 20, 10, 0. And those come in handy in a second. So we come up to 60, 80, or 80, 60, sorry. Draw our vertex. And now our slope is -4. And what we can do, if it's -4, that's each 1 to the right, it's going down 4. So if we go 10 to the right, it's going to go down 40. So if we go to 90, it's going to drop all the way down to 20. And we can put a dot there, leverage our axis of symmetry to put another dot at 70, 20. And there's our graph. Now, maximum sales in each week. Remember, our vertex is always the max or the min. And in this case, it's the max. So our Y value is 60. But remember, it's in thousands. So 60,000. So your maximum sales in 1 week was 60,000 singles. I'll let you pause here. And we're moving on to the next one. Oops, let me erase all this stuff. Okay. Now, we have 2 absolute value equations to solve, and we're told to check for extraneous solutions. Remember, those are solutions that will not work in the original when we solve algebraically. So the first thing we have to do is we must, absolutely must, get our absolute value expression by itself. So we're not going to mess with anything inside the absolute value bars yet. So we have this 1/4, oops. We have this 1/4 and this +3 equals 14. So we need to get rid of those. So we're going to get rid of the 3 first by subtracting from both sides. And we have 1/4 absolute value of 4x minus 6 equals 11 because we subtracted 3 from both sides. Now to get rid of the 1/4, the divide by 1/4 is the same thing as multiplying by 4. So we have absolute value of 4x minus 6 equals 44. Now, absolute value expression is isolated. Now we can drop the bars and we can write our 2 equations. So our first equation, 4x minus 6 equals 44. And our second equation, 4x minus 6 equals -44. So in our first equation, we're going to add 6 to both sides. So we have 4x equals 50. And then we're going to divide both sides by 4, and we end up with x equals 12.5. For our second equation, we're going to do the same process. We're going to add 6 to both sides. So 4x equals negative 38. Don't forget my negative. And then divide both sides by 4, and I end up with x equals negative 19.5. And because my x is only inside the absolute value bars, both of these are valid solutions. So if you want to hit pause, because I'm going to erase this so I can go on to the next one. All right, our second one's a little trickier because we have this x outside, but we're going to follow the same process. Step 1 is again to isolate our absolute value expression. So I need to get rid of this 4. So I'm going to add 4 to both sides. So I end up with x plus 11 equals 18 plus x. Now my expression's isolated, so I can drop my bars, write my two equations. My first equation is x plus 11 equals 18 plus x. And my second is x plus 11 equals negative 18 minus x. So we're going to flip the signs on both of them. Now on our first one, if we subtract x from both sides to eliminate the x on one side, we end up eliminating both of them. And we have 11 equals 18, which is a false statement, so we have no solution here. And then on our second equation, I'm going to add x to both sides to get rid of this minus x here. So that gives us 2x plus 11 equals 18. And then I'm going to subtract 11 from both sides. And I end up with 2x equals 7. Divide both sides by 2. And I end up with x equals 3.5. And so there's our one solution. In this case, we don't need to check for an extraneous solution because we have this no solution here, which would have been the problem. So hit pause if you want to, and moving on to inequalities. All right, inequalities. We're going to do the same approach. Isolate our absolute value expression to get this by itself. So we're going to divide both sides by 2, or by 6. So absolute value of 4x plus 20 less than or equal to 2. Now, expressions by itself, 4x plus 20 less than or equal to 2. And here's the difference. 4x plus 20 greater than or equal to negative 2. So when we write the second equation and we negate the right side, we also have to flip our inequality. Now our first one, I subtract 20 from both sides. I get 4x equals negative 18. Divide both sides by 4. And I get x, whoops, not equal to, less than or equal to. X less than or equal to negative 4.5. Second inequality, subtract 20 from both sides, and I get 4x greater than or equal to negative 22. Divide both sides by 4, and I get x greater than or equal to negative 5.5. So I come down here to the interval, and all I have to do is I'm just going to put my 2 points, negative 5.5 negative 4.5. Because we have our greater than or equal to, less than, equal to, closed circles. Since we're greater than negative 5.5, we're going to go this way. Since we're less than negative 4.5, we're going to go this way. So our interval is in between. And if we want to write in an interval notation, bracket, because they can be equal to, negative 5.5, negative 4.5, bracket. So pause if you want to. And let's go on to our second one. Same concept. So we have, first thing we need to do is get rid of this 12. So we end up with 1/2 absolute value of negative 4x parentheses, absolute value bar, greater than, subtracting 12 both sides, 8. Now we're going to get rid of this 1/2. So absolute value of negative 4x is greater than 16. Multiply both sides by 2. Now I can drop my bars. I have negative 4x is greater than 16, and negative 4x is less than negative 16. Now, another tricky, because we have a negative here, when we divide both sides by negative 4, we're going to flip the inequality again. So 4 is less than, or x is less than negative 4. Same thing here. Sorry. X is greater than 4. And there we go. So now again, negative 4, 4. This time we have no equal to bar, so open circles. So greater than 4, we're going this way. Less than negative 4, we're going this way. And so our regions are outside the 2 points. And if you wanted to, you could plug in a 0 right here to test this. So that would be 0 inside the absolute values times 1/2 is 0 plus 12 is 12. And 12 is not greater than 20. Therefore, 0 is not in our interval. Interval notation again, open circles mean parentheses. Parentheses negative 4, comma 4, close parentheses. Cool. Pause if you want to. And we're moving on. Sarah has $20. She knows that Blake has some money and it varies at most by $4 from the amount she has. Write the absolute value inequality that represents this scenario. So varies by at most $4 means Blake has her 20 plus or minus $4. So it's almost easier to do the second part first. So Blake has $16 to $24. Now, the absolute value inequality. The amount of money Blake has, let's call it M. M, when we subtract Sarah's 20, has to equal plus or minus 4. Which means, if we take the absolute value of it, the absolute value, has to be less than or equal to. The absolute value of M minus 20 is less than or equal to 4. And there's our equation. So the anchor value, which is Sarah's, because we know exactly how much money it is going to be subtracted from our variable and set in an inequality against the amount it varies by. All right, so you can hit pause, and we're going on. All right, so you're sitting in a boat on a lake. You get sunburned from sunlight, hits you directly, the sunlight reflects off the water, reflects off the water at 0.40. So 40, make sure we graph first, and hits you at the point 4.56. So 4.5 all the way up here at 6. Now we know, because reflects off the water tells us this is our vertex. And this is simply a point on the right side. So what we can do then is we need our slope for our equation. And slope is simply going to be the change in y over the change in x, rise over run. So we're going from 6, or we're going up, so it's the second value first. 6 minus 0 over 4.5 minus 4. And that's going to equal 6 over 0.5. And if we want to, we can double each of those. 12 over 1, which tells us 12. So our slope is 12. When we go over 1, we go up 12. So if we wanted to, our second point would be all the way up. Oops, here. But we can use our axis of symmetry. Since 4 is our axis of symmetry, we can come right here and draw another dot. And our graph is going to be a very, very, very tight absolute value function. Now our vertex, remember our formula is y equals a absolute value of x minus h plus k. Our point gives us, our vertex gives us our h and our k. So we have y equals, and this is our slope, and it's also our a value, 12 absolute value x minus h, so minus 4. And we have a 0 for k, so plus 0. And there's the equation of our graph. Pause if you need to. And we're moving on. Write the equation for each absolute value. First things first, identify our vertex. So our vertex in this case is 2, 3. Next, we want to estimate our slope. So we're going to come all the way down here to this first point where we have an intersection of the line of the graph with an intersection on our coordinate plane. And so we know we're coming right 1 and we're coming down 6. So down 6, negative 6 over 1, negative 6. So our slope is negative 6. And now we have everything to graph, or write our equation. So y equals negative 6, absolute value, x minus h, which in this case is 2, plus k, so plus 3. And there's our equation. Same thing for b. Find our vertex. So our vertex is at 2, negative 4. Our slope, if you want to draw a triangle, that's awesome. 3 and 3. So if we think about this, our rise and run are equal to each other. Therefore, our slope is 1. And we can write, let me write that down. M equals 1, which equals A. So we come over here and we have y equals x minus 2 minus 4. And there's your equation. Pause if you need to, and we're moving on. Oh, that's it. We're done. Cool.